Section 7.3 Interactive Assignment Objective 1. Use the accompanying data table to A. Draw a normal probability plot. B. Determine the linear correlation between the observed values and the expected z-scores. And C. Determine the critical value in the table of critical values of the correlation coefficient to assess the normality of the data. So first thing we want to do is we want to be able to draw a normal probability plot. So we're going to use the table here once we click on it to draw a normal probability plot. Now if we take a look at our choices, you should see that our choices give us the following. On the x-axis or the horizontal axis we have the observed value. On the y-axis we have the expected z-score. So let's go ahead and open up the table. So you can see here the first column represents the index, the second column is the observed value, the third column is the area according to the index of each particular value, and then the expected z-score is corresponding to the specific area in that third column. Now let's go ahead and open up in StatCrunch. So here we have our data. So what we want to do is, in order for us to take a look at the graph so we can see the observed and the expected z-score, we're going to go down to the scatter plot. We click on scatter plot. We want the x-axis to be the observed value. The y variable should be the expected z-score. And let's go ahead and select compute. And so now what we have is our graph. Okay, so now we can take a look at our graph. And then what we're going to do is we're going to compare them to each graph that we have here below. So let's take a look at part A. Here's part A's graph. When we take a look at this graph, it does not resemble this graph because you can see here that this is right on the value of -1, and this point is a lot closer to this corner here next to -1.5, and you can see that these points actually don't match as well. Let's take a look at B. Well, if we take a look at B, we can see here that this point is a little bit closer. If we drag this out a little bit longer here, okay, it could resemble this graph. This point is a little bit closer to this value over here, which it could be. You can see how this point is in between 45 and 50. And then there's these 2 points, and then there's those points as well, which could be a match. Okay, let's take a look at this graph here. If we look at this graph, this does not match our graph. And then if we take a look at this last one here, okay, we can see that this graph does not match. So it looks like the closest one that we have is B. So let's go ahead and check. So therefore that works, okay? Now what we want to do is we want to be able to determine the linear correlation between the observed values and the expected z-score. So opening up our data back up, what we want to do is we want to go to stat, and then we're going to go all the way down to where it says regression, and we're going to select simple linear, okay? So the x variable again is the observed value. We know the y variable is the expected z-score. And then what we're going to do is we're just going to come down here and then we're going to select compute. Okay, so taking a look here, right, you can see to the right there's our graph again. Now if we go here, here is the correlation coefficient. And we can see here that this is 0.9451, and rounding it to 3 decimal places gives us 0.945. So let's go ahead and put that in there, 0.945, and then check our result. Okay, and now what we want to do is we want to find the critical value. Okay, now in order to find the critical value, we're going to click here. It says to view the table of critical values of the correlation coefficient. But before we do that, we need to figure out what does n represent. So n represents how many values that we have. Well, we have 1, 2, 3, 4, 5, 6, 7, 8. So I just wrote this here. We can see that the sample size n is equal to 8. Okay, so coming back in here, we're going to click on the table of critical values, and then we're going to look at the value here, and you can see here that when n is equal to 8, okay, the critical value is 0.906. So we're going to go ahead and put that in here. So we get 0.906. Okay, now we need to determine, okay, to assess the normality of the data. So what we do is, okay, we know that the critical value now is 0.906. And now what we have to do is we need to determine whether R is greater than this critical value. Well, we found out that the linear correlation coefficient was 0.945, and therefore it is greater than 0.906. So because of that, then we can say that the data are from an approximately normal population. So when we answer our question, okay, we need to find out which one of these represents our value. Well, we know that the observed value, okay, so the correlation between the expected z-score and the observed value is greater than the critical value, so it's either going to be A or B. And so then we can say it is reasonable to conclude the data come from a population that is approximately normal. So that means we're going to select part A. And therefore, there is our result.